All right. So, first thing we need to review is quadratics. It's been a long time since we did it. It was the very beginning of the semester. And a quadratic is like a parabola that is a graph of a what degree? Second degree. Yep. In the form of y equals ax squared plus bx plus c. Okay. Where a is not equal to 0. These functions I just told you are called quadratics. And the blank of the parabola is located on the blank. Vertex. On the axis of symmetry. Okay. The x-intercepts are located at negative b plus or minus the square root of b squared minus 4ac over 2a. What's that called again? Quadratic formula. Okay, so you can use the quadratic formula to find your zeros, or you can factor by hand. You can use the box method as well. Okay? All right. So there are 6 steps to graphing a parabola. The first step you need to remember is that you need to determine if it opens up or down. If it opens up, your a value is going to be greater than 0. If it opens down, your a value is going to be less than 0. Second, you need to determine the vertex. There's 2 steps to that. First step is to find the x value. The x value is negative b over 2a. Okay, once you find that x value, you're going to take whatever that is, whatever this is, and you're going to plug that back into the equation. To find the y value. Okay? Number 3, we are going to look for x-intercepts. We find that when we set y equal to 0, and we can use quadratic formula. Or we can factor. Step 4, y-intercepts. How do I find a y-intercept? I'm going to set x equal to 0. And no matter what kind of function you have, that's how you can find the x and y-intercepts. Okay? It could be a rational function like we just learned last unit. It could be a linear. It could be anything. Okay? And then the last part, number 5, is plot intercepts and vertex. And notice it said 6 step, but we only have 5 here. So what do you guys think the 6th step should be?
Graph.
Well, we graphed the points, so now we're going to connect the dots. All right. In a minute. Okay, so on this part, we're going to actually go through and do our six steps here. So number 1, we need to find out if it opens up or down. So my a value is what in this case? negative 1, which happens to be less than 0,
Which means it went down.
it opens down. Okay, so that's the first thing we know. Number 2, we need to find our vertex. So we are going to take x equals negative b over 2a. What is our b in this case?
Negative 2.
It's negative 2. So negative of negative 2 over 2 times negative 1.
Negative
2 over negative 2, which ends up being negative 1. Okay, that's our x value. Now that we know the x value, we've got to plug that back in to find our y value. So it'll be y equals negative 1 squared. Now make sure you put that into parentheses, or you might end up with something totally different in your calculator. No CASs on the test. Only non-graphers. Okay, so this ends up being a negative 1 plus 2 plus 3, which ends up being 4. So our vertex in this case, the x value is negative 1, the y value is 4. Negative 1 here?
No. Like negative 1. Down. Right there.
Oh, right here? Because if you notice here, there's a negative outside the x.
So then once you fix that, wouldn't it be just 1?
Well, negative 1 times negative 1 is
1.
positive 1, plus the negative in front of it makes it negative again. So that's why you get this. Okay, that's part of the reason why it's really important to use those parentheses if you're using your calculators. Okay, number 3. We want to find the x-intercepts. So in order to do that, I'm going to set 0 for y. So we have negative x squared minus 2y plus 3. I don't know what I said. Negative x squared minus 2x plus 3. Sorry. Here's the thing. This one looks pretty easy to factor by hand. If you're going to factor it by hand and you have a negative a, you need to switch all your signs. It makes it easier to factor. If you're going to use the quadratic formula, you don't need to switch your signs. So make note of that somewhere on your page and remember that, because that's an area that people mess up. So if you have this, and if I go to actually factor it the way I want to do it, I'm going to change my negatives to positives and my positives to negatives. So because I'm factoring by hand, it's going to be 0 equals x squared plus 2x minus 3. My factors on this are going to be x plus 3 and x minus 1. You can use the box if you need to for that one. So if I set both of those factors equal to 0, just like we did on the rational unit exam when we were looking for the vertical asymptotes, set them both equal to 0, my x value is going to be a negative 3 and 1. So that would be negative 3, 0 as a point, and 1, 0 as a point. We have one more step that needs to be done before we start graphing. Find the y-intercept. So y is equal to this whole equation from its original form, and we're going to change our x's into 0. So it'll be minus 0 squared minus 2 times 0 plus 3. Now obviously these two cancel out, so I just get a 3. So my y-intercept is 0, 3. So graphing that. If I plug in this for my vertex, -1, 4, I'm going to go over to -1 and up 4. So my first point will be right here. My intercepts are -3, 0, and 1, 0. And my y-intercept is at 0, 3. So I can connect these dots now. I know it opens downward. So here you go. This is what I got for the second one. All right, so if you guys did this problem on your own, you should have gotten it opening downward, an x value of 1, plug back in to find a y value of 7, so your vertex would have been 1, 7, which is right here. If you make it equal to 0 and use your quadratic formula, you should have gotten -0.90 and 2.90. So that's where these 2 points are. Plugging in 0 for y, you should have gotten 5, so that's where you got this one. All right, there's there's several applications that you can use for quadratics. And you guys aren't frozen, are you? Okay. And what you got to remember is whenever you do a rocket or something, whatever goes up must come down, right? So you're going to have that parabola shape and things. So let's look at this first one. It says fireworks are launched into the air, and it uses this quadratic function to model the fireworks' height in feet x seconds after launch. So if I made this firework go up into the air and come back down, we want it to explode where? What? All right, so we want it to explode where? At the top, right? We don't want it to explode down here. We want it to explode up here. So we want our fireworks to explode way up here, right? At the very top. What's that called at the top of a or? Vertex. Yeah, the math one is one that we want, not the peak. But so it's called the vertex, okay? So we want it to explode over the maximum height. How do I find that vertex? Uh-huh.
Okay, never mind.
So x equals -b over 2a. Okay? Yep, so that would be equal to -212 over 2 times -12. And I think what you end up with is 8.83, something like that. You'll have to check. Okay, so that was part A. How do I find part B? Yeah, plug it back into the equation. We need to find the y value now. Okay, so for part B, we'd say y equals -12 times 8.83 squared plus 212 times 8.83 plus 3. Okay, that's the height. So after 8.83 seconds, they exploded at a height of some kind of feet. And I don't know what it is because I didn't actually figure it out. But you guys can do that. So the cost in millions of dollars for a company to manufacture X thousands of automobiles is given by this function. Find the number of automobiles that must be produced to minimize the cost. So what kind of a parabola is this? It's opening upward this time. Notice that the a value is a +4. So if we want to minimize the cost on this one, where is that? The very bottom at the vertex again. So we need to find x equals to -b over 2a. All right? So I'm not going to actually walk through this, but you guys can use that to do it, okay? and the next one I wanted just to walk through a little bit was number 3. It says a ball is thrown straight up from a height of 4 feet with an initial velocity of 22 feet per second. So starting at 4 feet, we're going to say right here, that's 4 feet. And then eventually it goes up, it comes back down. Okay? So we want to know when the ball hits the ground. That's right here, correct? Notice that if I go backward in time, if I extend that parabola, it's going to end up with a negative t right here, correct?
Yeah.
So you're going to have two values that come out. Which one do you use? The negative one or the positive one? Positive one, right? So we're going to set this equal to 0. Whenever you're trying to find your intercepts, you're going to use the quadratic formula or factor it. Okay? So here's our values. We'd have A equal to negative 16, B equal to 22, and C equal to 4. Only if you're not using quadratic formula do you change the signs. Okay? So we're using the quadratic formula, so we don't have to. So this will be negative 22 plus or minus the square root of 22 squared minus 4 times A, which is negative 16, times C, which is 4, all over 2 times negative 16. And I'm not actually going to sit here and figure that out for you either. You can put that in your calculator. But I just wanted you guys to see how you set it up. So the fact is it wants to know when it hits the ground again. You're going to use x-intercepts. Okay? So we have this, and we have y equal to 1/2. We're just going to rewrite it where you have the y changed into that value, like so. Now, most of you probably don't like fractions like I do. I don't like fractions, and I'm a math teacher, and I don't like them. So, I always look for the way to get rid of them, and so how do you get rid of them? Common denominator. I'm going to multiply the entire sentence by what? By what? Nope. Common denominator. What do they all multiply into? Smaller than 12. 6. Okay? So this will be 6 times x squared, and then the 6 cancels out on this one, so it'll be plus 17x. And then 6 times 1/2 is 3. That looks a little friendlier to me. Okay, so now we want to get everything to the left side because we have this 3 over here. How do I get that moved over? Minus 3. So it's going to be 6x squared plus 17x minus 3 equals 0. Okay, how do I solve that? So I either need to factor it or I need to use the quadratic formula. So I'm not going to do that right now, but that's how you would do that one. Okay, number 2, you do the same way. Number 3. What do I do to get rid of that denominator? Times everything by x. So you're going to have x squared plus 5x equals 6 and do the same thing. Okay? Okay. Number 5. What do I do on that one? Yeah, so multiply the entire thing by x minus 1. Get rid of that. So it cancels this out here, it cancels this out, but we're going to have x times x minus 1 plus x equals 4x minus 3. It's the denominator. I'm multiplying each thing by this x minus 1, so it will cancel out the denominators here. Okay? So this will be x squared minus x plus x equals 4x minus 3. Look what happens to these x's. They cancel out. So I have x squared equals 4x minus 3, and I'm going to move those to the other side, so it'll be minus 4x plus 3 equals 0. And then if this one's actually easy to factor, I don't even have to put that in the quadratic formula. What would the factors be on this one? Okay, x minus 3, x minus 1. Can set them both to 0. So x is 3 and x is 1. So now we're going to take this portion and look at exponents. And the first part is an exponential curve is the graph of, and you can write this down, y equals b to the x. You can also say f of x equals b to the x. Notice that y is the same thing as f of x. Okay? And this is where b is greater than 0 and b is not equal to 1. So if b is greater than 1, what's that called? Growth. It's getting bigger, right? If b is greater than 0 but less than 1, what is that called? Yep, decay. The y-intercept of the graph is at, think about it, if I put 0 in for x, so it's 0, 1, yep. The domain of the function, if you look at this graph, if I draw this for you right now, it looks something like this. So what are the possible x values? All real numbers. Okay? I always write it like that. It's the same thing. The double-sided. Okay? The range, the possible y values are what? Non-negative.
How do we know the y-intercept is 1?
Because for the y-intercept is 1 is because here I have y equals b to the x. And if I put 0 in for x, anything to the 0 power is always 1.
Oh, okay.
Okay? The graph of it has an asymptote. Where's the asymptote in this case? It's the x-axis. Okay? And the irrational number, e, appears as the base of the function in many applications. The one I remember the most that you've used this semester so far is a equals p-e-r-t. When do you use that again? Yep, compounding interest, and it's when it's continuously compounding, right? So you see it a lot in banking. That's the one I see the most. And maybe some biology stuff. Okay. Now, if you notice down below, it says complete the table, then graph the exponential function. There is no table, and there is no function.
I think the table finished.
It might be on the next page.
No, I think the table.
Oh. So there's no exponential function there. So I'm going to find out what that's about, and I'll let you guys know. But go on to the next page. We have a couple applications here I wanted to talk about before I let you guys go for today. Okay. This one is directly off one of your unit tests. If you guys read this, you'll probably recognize it a little bit. Says for a certain country, the exponential function is describing the population y in millions, x years after 2000. This is where people messed up. Okay, so it says find the country's population in 2000. So how many years after 2000 is 2000? 0. So for this one, you would put 0 in for x. So anything to the power of 0 is 1. So this basically goes away, right? So the answer to this would have been 47.84 million people.
Hold on. I wouldn't go way over
Anything to the 0 power is 1.
Oh, no matter what.
No matter what. Okay, so now in 2028, what's my x value? 28. So it'll be 47.84 times 1.027 to the 28th power. So you plug it in and find out what it is. Number 2 is the same kind of thing. The function, blah, 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 there it is, models the percentage of information, f of x, that a particular person remembers x weeks after learning the information. So, A is at the moment it is first learned. How much information are you going to remember? Well, x will equal 0. So if you plug that in, it'll be 70. Anything to the 0 power is 1 plus 30. That's 100%. You should know right away, right? After 2 weeks, it'd be 70 times 0.817 to the second power plus 30. Whatever that is. And then 10 weeks would be 10, right, in the x value. Right? So, for tomorrow, you need to do section 2, logarithms. Okay, that's all that page and the next. Okay? And you also need to work on the following page, which it talks about rational expressions review. And then these nice little story problems after that. So 4 pages worth of stuff, but you have a final on Wednesday, so this will be part of your studying.